Hello everyone, very good morning. A quick introduction for them who is new to this channel. My name is Subrat. I have 10 plus years of experience in both IT industry and teaching. This course may be one of its kind among all available free and paid courses throughout the internet. It is designed to make you a complete full stack TypeScript developer, teaching you everything from DSA to front end, back end, mobile development, and generative AI implementation. We are now covering our first module, DSA, through TypeScript. And today's problem is to find the next permutation. Okay, this is our problem statement. Generating the next permutation. Imagine you have a list of numbers, say 1, 2, 3. You can arrange these numbers in different ways, like 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. Right? Now, this chapter is about finding the very next possible arrangement of a list of numbers. When you arrange all possible permutations in ascending order, just like words in the dictionary, this is formally known as the lexicographical next greater permutation. Suppose you have given 1, 2, 3. So the next permutation is 1, 3, 2. If you have given 3, 1, 2, then next permutation is 3, 2, 1. But what if you have given 3, 2, 1 and interviewer asked to find the next permutation? So the next permutation will be 1, 2, 3. Okay. Suppose 2, 1, 3 is given to you. Then next permutation will be 2, 3, 1. Got it? So notice how 3 to 1 is the largest possible arrangement for this case, and the next permutation is the smallest one. The list sorted in the ascending order. Okay. Now, in brute force approach for finding the next permutation is simple in concept but incredibly slow in execution. It completely ignores the mathematical structure of permutations and relies on raw processing power. Here are the 3 steps, a high level overview of the brute force approach. First, generate all the permutations as we did here. Okay. Then sort the permutations in dictionary order. Then search and identify the next permuted number. Okay, this is the brute force approach. But the brute force approach achieves the goal. That's fine. Okay, but why it is impractical? The drawback, the reason behind this is it generates all the permutations of a list of n elements, which takes n factorial time. So for a list of just 10 elements, you have over 3.6 million permutations to generate and store. For a list of 20 elements, the number of permutations is astronomical large, right? So in contrast, the efficient 4-step algorithm covered in this chapter only checks the list once, okay, running in a linear time. Now, what is 4-step algorithm? Let us take an example of this array. In 4-step algorithm, first we will find the pivot. Okay, I will explain the steps one by one. But first, let's see what are the 4 steps. Find the swap element. Okay, then swap the numbers, then reverse the suffix. Now, what is find the pivot? The breakpoint. We scan the list from right to left, looking for the first element that breaks the non-increasing trend. Okay, and we call this the pivot. So let's start from the second last element. Okay. So here, let's compare these two elements, 3 and 0. Okay. So we move to the left. Now 4 and 3. Is 4 less than 3? No. So let's move to the left. 5. Is 5 less than 4? No. So let's move to the left. Now we have 1. Is 1 less than 5? Yes. 1 is less than 5. So 1 is our pivot number. Okay. And what is its index? Its index is 2. Got it? This is our step 1. We find the pivot which index is 2 and the value of element is 1. Now, the right part of the pivot is the suffix. Okay? And it is in descending order for now. We will come to that point later. Now, step 2. Find the swap element. Now that we have the pivot, this 1, we need to find a number on the right side, in the suffix side, that is just slightly larger than the pivot. We call this as the swap element. Okay. So let's scan the suffix. If you scan all these 4 elements and compare with pivot, the number which is larger than 1 means next larger number, right? Which is slightly larger. That is 3. Right? 0 is less than 1. So 3 is slightly larger than 1. Means next largest number, you can say. Okay. So we covered step 2 here. 0 is not greater than 1. 3 is greater than 1. So the swap element is 3, which is at index 5. Okay. I have written index numbers here for the clarity. The below are the index numbers and these are the elements or values of that specific element, right? Now step 3, swap the numbers. So we will swap this pivot number with this swap number. Okay, means the index 2 to index 5. We will swap these two elements. So after swapping, what we got? We got the new number 6235410. Our earlier number was 6215430, right? We swapped 1 with 3. So we got 6235410. Okay. Then fourth step. Here, if you see the suffix 5410, even after swapping, is still in descending order, making the resulting number large. So we will reverse this suffix 5401 and after reverse we will get 0145, which is the actual result that we want, 6230145. Okay. Now let us solve this using TypeScript. And will it work for all the numbers? Okay, don't worry, we will try with hundreds of numbers and see whether it is working fine or not. Okay, this function will accept a numbers array and will return a numbers array as well. First, we will create a copy of that using numbers.slice. If you want to know about slice and splice, the difference between these two, then you can go to the channel. We have already a video on this. You can see somewhere here. Yes, slice and splice. Okay. Now, the first step. Start from the second to last element and move towards left. So we will find the second to last element I, which is our starting index, and from there we will move towards our left, okay, till this condition satisfies, right? Then the second step, if a pivot is found, okay, Then find the smallest element in the suffix in the right side that is greater than this one. Okay, since the suffix is in decreasing order, we can scan from the right and stop at the first element greater than the numbers of index. Then step 3, swap the pivot and swap the element. Then step 4, reverse. For reversing, we are using two-pointer technique, and we have already discussed about two-pointer technique in a previous video. You can go and watch that as well. Now we have used many test cases to test this, whether it is working fine or not. And you can see here the results. With the input we gave, and it is passing for all these 118 test cases. Okay, if you still have any doubt or any confusion, you can comment, or you can join our Discord channel. If you have watched up to this point, then you can join our Discord channel and ask if you have any doubts there, or you can discuss with your peers and learn and grow. Thank you everyone. Thanks for watching. Bye bye.